Good afternoon, sir. My name is Manideepa. I am from CSE B section, second year, second BTech. Today I am going to explain about a problem using hypothesis testing for bulb life expectancy. Before going to problem, first we have to know what is hypothesis testing. Hypothesis testing is a fundamental statistical method used to determine whether a sample data set supports a specific claim about a population parameter. It helps in decision making by evaluating whether the observed results are due to chance or if they are reflect a genuine effect. And next, some of the key points of hypothesis testing are we have four rules H naught, H1, mu, alpha, and Z. H naught represents the null hypothesis, H1 represents the alternative hypothesis, and alpha means level of significance and Z means test statistics. And then we have conclusion also. In conclusion, we will be accept either H naught or H1. So first we have to know H naught. H naught means null hypothesis, the assumption that the claim is true unless proven otherwise. And next H1. H1 means alternative hypothesis. The hypothesis is that we want to test. Z test is the statistical method used when a population standard deviation is known. And significance level, and it represents alpha, the probability of rejecting a true null hypothesis. Critical value, a threshold from statistical tables that determines the rejection reason. And next decision rule, if the test statistics is beyond the critical value. And the problem is a sample of 26 bulbs given a mean life of 990 hours with a standard deviation of 20 hours. The manufacturer claims that the mean life of bulbs is the 1000 hours. Test the sample, not up to the standard. Here we will give the sample data, sample mean, and the lifetime of the bulbs. So by using these data, we will be calculate the hypothesis test and test statistics. Since the sample size is greater than the 30, so that we will be normalize use a test Z test. But since the population standard deviation is known, we still use the Z test formula for population mean. The formula for Z test is Z equals to x bar minus mu by sigma by root of n minus 1. And here x bar equals to 990, and this is the sample mean, and mu equals to 1000, sigma equals to 20, and sample data n equals to 26. If a random sample of size n has a sample mean, to test hypothesis data that the mean population mean has a specified value u naught when the standard deviation is not known. The statistical is given by t equals to x bar by mu by s by root of n minus 1, where x bar equals to sample mean and mu equals to population mean and s equals to sample data. And in the problem, what the given data is sample size, sample mean, and standard deviation and population mean. So sample size n equals to 26 bulbs and the sample mean equals to 990 hours, and standard deviation is given 20 hours and claimed population mean is 1000 hours. And let we have to find degree of freedom. V equals to n minus 1, where n equals to 26 and 26 minus 1 equals to 25. So next level of significance is 0.05, because in the question they didn't mention significance level. So by defaultly it will be taken as 0.05. And next null hypothesis, H naught equals to mu equals to 1000. And next alternative hypothesis H1, mu naught is not equals to 1000, and level of significance is 0.05. And next we have to find the statistical test, and the formula of statistical test is x bar minus mu by s by root of n minus 1. Here x bar equals to 900 and mu equals to 1000. Standard deviation is 20 and root of n minus 1 is root 25. So after we calculate, we have the solution of t is 2.5, and next we have to find conclusion. T naught equals to, we have to divide by answer into 0.05 by 2. Then we find 2.06 and t is greater than 3 alpha. So we reject the null hypothesis. And conclusion. Based on our hypothesis test, the sample data provides sufficient evidence to reject the manufacturer's claim. The bulb's mean lifetime expectancy appears to significantly lower than 1000 hours. This suggests that the bulbs are not up to claimed the student. And thank you, sir.